Welcome to another highly technical talk. Thank you, Stephen, for spending time with us today.
Thank you for inviting me.
We started doing a highly technical talk once because someone in a marketing meeting once said that people don't come to see highly technical talks. So then we named the talk Highly Technical Talk in order to troll them, because then in the follow-up marketing meeting they had to say, well, it looks like Highly Technical Talk did well. So then they gave us another talk. If you're not familiar with Stephen and his work on the .NET team, he is fantastic, and we appreciate you. Everyone knows Stephen Toub. Every time that I get to hang out with you, I learn something.
Ditto.
And we started hanging out together, and I said, can I just record us hanging out? And then we turned that into a series called Deep.NET, and we've also had wonderful other .NET engineers and architects from the team on. So this is going to be full of slides and diagrams. I know there's a lot of PowerPoint. No?
If that's what it was supposed to be, I forgot to prepare it.
Okay. So we have no slides at all.
This is my slide.
That is your slide. Okay. So what are we going to do here?
Well, I've had a lot of fun at Build. There's a lot of stuff about agents and MCP, which is great, but I'm feeling a little agent out.
Okay.
So we're not going to do agents. We're not going to do MCP. We're just going to write some .NET code.
All right.
And what I thought would be fun, I was talking to some developers here yesterday. They were talking about the Deep.NET series and how they really liked sort of the approach of building things from scratch and using that as a way to learn sort of the mental model behind how something works. And then I was talking to some other people, and they were talking about having just discovered the system threading channels library and how it perfectly met their need for what they were going to do. Mm-hmm. So what I thought we would do today is re-implement the system threading channels library.
So you thought, as a casual aperitif, and amuse-bouche of sorts, we would implement channels from scratch.
Yeah, we have like 50
Are we doing it in airplane mode just to make it hard? Or?
Sure.
He's like, yeah, I could do that in airplane mode. I know, you were like doing the calculus.
I mean, the thing is, we can talk more about what channels is, but it's actually, at its heart, it's a really small thing. Mm-hmm. And so it's actually, as we'll see, not that hard, but that's kind of the point, because it'll drive home exactly what it is and how to use it, and people will walk away with a much better understanding of what that means and when it'll be relevant to them.
I love it. Let's make sure that we get a level set here. Who knows what threading, system.threading.channels is? Okay, who here have just heard that today? Okay, so about 50-50. There's a lot of people here who may have channel-shaped problems.
And not know that there's a channel-shaped tool.
Let's do it.
Great. So, channels is in the system threading channels library. This is part of .NET Core. When you install .NET, it's just there. If you're not using .NET, if you're using .NET Framework, you can grab the NuGet package, which has been downloaded, I think, about 1 billion times at this point.
Billion?
1 billion with a B.
Wow.
It is, at its heart, a little data structure that allows you to implement producer-consumer problems. So if I can have a channel, let's just have an int, and I can say channel.create, and I can have various kinds. I'm going to create an unbounded one. All that means is, other than being subject to the limits of the memory in my computer, there's no artificial bound on how many things can go into this channel, like a queue or a list. It has a capacity.
Okay.
And then we're going to have a producer, and we're going to have a consumer. So I'm just going to spin up a task here. Task run. Sorry, I'm used to sitting down when I type.
Now, this thing here that's happening is ghost text. You like that?
I do like it. I could turn it off.
No, it's fine.
Okay.
I think the point is that this is not an ad for Copilot. This is literally your computer. This is how you use it. You're on a ThinkPad. You're in light mode. There's nothing, you haven't changed
this is how I write code. I have 50 minutes to re-implement channels, so I'm going to take all the help that I can get.
All right. Touche.
Yeah. So here I have a producer, and all it's doing is it's looping from 0 to 10 and writing this data into a channel, just like adding to a list or into a queue.
Okay.
And then I'm going to have a consumer that is just going to sit in a loop. True, I can't see. True. And we'll just print out, IntelliSense is getting in my way, the result of reader.read async. Right? Let me make this a little smaller so we can see. So I've got my producer and I've got my consumer. And just so we can see what's actually going on, I'm going to slow down my producer a little bit. So my producer is going to produce one thing every second, and then it's going to mark the channel as done, and the reader will basically wake up with an exception saying you're trying to read from something that's
When you mark it as done, you're marking it as done for all time?
for all time.
Okay.
Yeah.
You're
And
closing.
These are lightweight little data structures, so you can create them, mark them complete.
Okay, so it's not a thing that you open when the app starts and keep open forever?
No, in fact, I can show some examples of how that's very much not the case.
Okay.
So you'll see it's looping. The producer's writing into this once a second. The consumer's immediately waking up. And then when it gets to done, it's going to say, hey, the channel is closed.
Okay.
So it's a very simple producer-consumer. And these show up all over the place because anytime you have this, where you want to have one thing over here that's sort of just throwing data over the fence, and then something over here that's doing something with it, channels are a perfect fit. So if I search for channel in source.net, and I click this,
If you're not aware, of course, he's at source.dot.net.
which is an index of the core repos.
Yeah,
in
it's the source code for .NET. You can look at it on GitHub, but this is a really nice, attractive way to look.
And you can see if I just scroll through, the Aspire dashboard is using channels. A lot of tests are using channels. Aspire hosting is using channels. Then there's a bunch of other tests. ASP.NET Core itself, the Kestrel server for HTTP2 is using channels. Signal R.
Is there something that I might want to do to look at my code or think about what I'm implementing at work right now and go, oh, shoot, I shouldn't have done that. I should have used channels. Is there a class that I would be using today?
There's probably a whole class of problems that will look like the code we're about to write.
All right.
Where you are yourself, you have a lock, and you've got a queue, and you're protecting the queue while you write into it, and someone else comes along and reads from the queue, and then maybe you have some kind of notification to say, hey, I put something there, wake up now. Mm-hmm. That's what these things look like.
All right.
And just to sort of, we're going to try and stay pretty far away from AI, but just to kind of highlight the sort of the transient nature of these things, that it's not just create one and startup. This is the most recent example that I used, where I used the channel. This is part of the Microsoft Extensions AI library. And this is going to basically be done once per request that you send. So when you say get response, or in this case, get streaming response async, we're creating a channel, and we're doing it because the way this is set up, someone's going to call get streaming response async over here, and that's going to go through a layer that isn't passing the data back, and it's going to call to something over here that is creating the data. And so somehow that data has to get from here past this layer to over here. And so we create a channel for it to just kind of bypass it. So it's just an example. You can see we're creating a channel. In this case, it's bounded, so we do have a bound on this. We have a producer writing.
And are channels something where they're just sitting inside of a variable, but are channels named things that I can pull from somewhere else? Can I pass that variable around? Like, what are the rules about channels living on threads? Or
they're just the data structure.
Just
put it
the
wherever
data
you
structure.
want. Wherever you would put a queue. If you wanted to put a channel in DI, you could. If you wanted to have one in a static, you could. If you wanted to have it in a variable that you passed around, you could.
Okay.
Whatever you want with it.
Dependency injection is DI.
Yes, sorry. So right now we can see that I'm using basically 3 methods from channels. I'm using write async, I'm using complete, and I'm using read async. So let's start there with implementing our own. All right, so I'm going to come in here and I'm just going to say my unbounded channel. And I will try hard to ignore the ghost text because I actually want to, but I'll accept it sometimes.
Well, sometimes you want to drive stick shift.
Exactly. So we're going to have 3 methods. We're going to have write async, and write async is just going to take t item. And then we're going to have read async, and we're going to have, see if it does, yeah, there we go. All right.
And value task.
Value task is just a lighter weight task. So it's particularly valuable when you have a task of t. And in this situation, it's valuable because a value task is basically a discriminated union between a t and a task of t. So if you look at the data structure, value task of t, it's got 2 fields, t and basically task of t. And the nice thing about this is a struct in a situation where the async method that I call is likely going to complete synchronously and hand back data. I don't have to allocate anything. I can just hand back a value task of t, in which case its t field will be filled in, and its task of t fields will be null. And in the case where things complete asynchronously, the t field will just be default, and the task of t field will be filled in.
Take it.
Waving my hands a little bit because it's evolved a little bit since then, but it's good enough for this. All right, so I've mentioned the word queue several times. We need somewhere to store the data that we're writing into this thing. So I'm going to come in here and I'm just going to create a read-only queue of T. We'll call that items. And now we can start filling this in. Actually, I'm going to do one more thing, and that is I need a lock. I do need some synchronization here. One of the things that I personally like to do, just from a style perspective, is I like to have some property that returns the object that I'm going to lock on. And that way I can write all my code in terms of that property, and I can change later on what exactly I'm going to use for a lock. I could just say this is some new object, but I also am sort of an efficiency guy, and so I often will just reuse some object that already exists.
Okay, and it's grayed out because it's not being used.
Because I haven't used it
right now.
So now we're going to come in for our writer, and we're going to add this item into our queue. And then say that we're done by returning, in this case, default for a value task just means it's an already completed value task.
Just as a stylistic thing, I noticed that you're really good at both ignoring the ghost text, but then also going, oh, yes, I want that. You think about it as a spicy autocomplete. When you see it where it's going, you keep going.
For me, the ghost text generally ends up being a faster way to type. So I have in mind what I want to write, and if the ghost text pops up and it's exactly that, I accept it. And if it's not, I just...
But since you know what you want to write, you can just ignore it.
Yeah.
Okay, cool.
Yeah. Now we're going to come back here because this isn't fully complete, but we're going to start implementing read async, and then we're going to see what we need. So in read async, we're also going to lock. Now in this case, I'm going to get rid of this. We'll start over. So I'm going to say if there is anything in my queue, try dequeue out of our item, then I'm just going to return it. Right? So this is the good case where there's already some data, and we can just hand it back. Now, the harder case is what happens when there isn't any data. So this thing now needs to wait until there is data, which means it needs to create basically a task that it stores somewhere that a writer can then complete when a writer comes along and has some data to give us. So I need another queue here. And in this case, I'm going to have a queue not of T, but of task completion source of T. We're going to call this readers. And then our reader can just say, task completion source of T. It'll create a new one. We'll store it in, and then we'll return the value task out around that.
So task completion source of T is effectively a post-it note that you're putting over here to let me know when you've got stuff, I'm ready for you.
Yeah, it's a promise for, promise is a loaded word here. It is a way of creating a task that I can later complete.
Okay.
And I hold on to the producer side of it, the task completion source, and I give you the task. And then at some point I come along and I poke it, and I say, here's your result, and it kind of flows through me to you.
Okay. I'm trying to understand, I'm trying to visualize this because I want folks to visualize it, but I'm also trying to understand, like you've got a decision in mind and you put your finger on the chess piece, but you don't actually make the move official till you take your finger off the chess piece.
I'm giving you like an envelope and I say, don't open it yet. I'll tell you when you can open it. And then somehow I magically get the result into the envelope.
Okay, I like that analogy. Good job. Science.
Exactly. Now I'm just going to be doing jazz hands.
Yeah.
All right, so now we need to tweak our write async a little bit. So we're not just putting something into this queue. We first need to check if there's already a reader. So if there is already a reader, then rather than storing into our queue, we're going to just pull the next reader out and directly hand them the data. We're going to fill in their envelope, and we're going to say, hey, now you can look. Right? Otherwise, we'll push the data into that queue. Right?
Cool.
So that's two of our methods almost done. And now we have complete, which is the thing that's going to mark this thing as done. And so I need some sort of marker here to basically know when I've been completed. And our complete.
Okay. I was going to wonder if you were just going to mark it as complete or if you were going to lock on that object.
Exactly. So I'm going to lock on the object and I'm going to mark it complete. And there are ways that we could make this more lock-free. And if you look at the implementation in the runtime, it is more lock-free. And we'll get to that a little bit here. But this is good enough for understanding the mental model behind how this works. So we're marking this as completed. But then there might still be some readers who are sitting there waiting for data when it's marked as completed. And if we were to just let them sit there, they would never wake up. They'd be hanging out there forever.
So this is just tidying up.
So we're going to tidy up, and I'm just going to come in and for each of them, I'm going to give them an exception. and I'm going to say channel is completed. So
Is this an edge case? Like literally, are you handling an edge case? Are you going to find, you're not going to find millions of things when you hit complete, but you could.
I could.
Depends on how
Depends
intense.
How many people decided they wanted to be notified of the next, read the next thing.
Okay.
So it's possible. And then we can also do some things like if someone tried to write when it was already completed, we can throw an exception. And to be a good citizen, we actually probably want to do value task dot from exception instead of throwing, because the contract with async methods is that you.
So you're not tossing an exception, you're tossing that.
I'm returning out the task.
I wish there was an exception.
When someone awaits that exception will get thrown.
Got it.
And then similarly here for reading, if it's completed, will similarly fail.
Okay.
That's it. Now we've got kind of the core of our channel in place. And with any luck, if I come up here, and we'll just make this var, let me change this to.
So now you are not going to use
I'm not going to use the real one.
system.threading.channel. So you just get rid of that whole using statement.
Yeah, and
top there that got grayed out.
Channels splits out the reader side from the writer side. I just put it all in the same class for simplicity.
Okay.
But if we run this, oops,
So you just made a channel-shaped thing and are no longer using
That's
the
right.
channel that we ship.
and now if I run that with any luck, we should see the exact same behavior that we got before, writing one thing a second, the reader's waking up, and when it hits approximately 10, it'll get an exception saying.
Would you call this a naive implementation of channel or a simple?
Simple implementation.
Simple.
Of channel. There's nothing wrong with it. I mean, maybe I have a bug somewhere and that's wrong with it, but at its core, this is pretty simple and good enough code. But we don't want people to have to write this code, and we don't want to have to write it a lot, and we want to be able to provide a more optimized one, so we provide something that is actually channel so they can go use it. Now, this usability isn't great, because if someone's calling complete, that's not really an exceptional situation. In general, I want to read while there's data, and then when there's no more data, I want to wake up without an exception. So while I can do it this way, with actual channels, you would generally consume this in one of two other ways. One way is to say, there's a method called wait to read async, which I haven't yet implemented, which is basically, it's like a peek. It's a notification that there's data available without actually taking it out. And then I can read. So I can say, then try read out var item. So this is one way that you might consume. In this way, when there is no more data to read, the wait to read async returns false, and I exit out of my loop nicely. Now you'll notice that I haven't implemented these yet, so I'm getting squiggles. So let's implement them.
Do you like to do that? Do you like to do you write the method and go, that feels the shape I want, and now I just need to do the work inside of each of those two squiggles?
I do. Certainly from an API design perspective, it's really helpful to understand what the consuming code will look like. So I'll often start from what would I like this to feel like, what would I like this to be, and then I go and see if I can make that work and how that would work.
Mm-hmm. How often do you find that it doesn't work the way that you can't make it shaped like that?
It's pretty common to find that I could make it work, but I could make it work better a different way. And then I iterate and tweak.
All right, cool.
Yeah. So we need to implement these two methods. Let's start with read async, because that one is easy. So we'll say try read.
I'm interested. You're typing it there, though, as opposed to going back and telling IntelliSense to make you one that's shaped like that.
Yeah, I always forget that exists.
Yeah, control dot or whatever.
Yeah.
Okay.
Yeah. But yeah, I could have just done that.
Just curious.
That would have made sense.
Now, hey, you're the expert.
Well, apparently not. So we're going to, again, lock here. And this is a very simple, if we can dequeue an item, great. Now, I would also want to say if it's already completed, return false. But I don't need two different cases for this, so I can just consolidate it to that. And then as it turns out,
Got an extra one in there.
Yep. We've got some junk down here.
Just got very falsy.
I don't know. Oh, there's a little, I somehow managed to type a little.
Are you a
Backtick.
Are you a KNRC person? Do you like your curly braces like this, or do you like them like that?
I like them aligned.
You like them aligned.
Yeah.
So you like this line.
I do like
You like
this.
the lines?
It feels very comfy to me.
Okay. I'm glad it feels comfy for you.
So we can actually, we can just have the simplify that down to that. Now this is interesting. You notice I'm getting.
I know that I've got to ask you when you expand your three-letter acronyms, your TLAs, you got to tell people do that again, because I feel like sometimes it goes like and then like a thing happened. So there you go. just want to make sure that people follow what happened there. Nice
sorry.
little simplified. No, don't apologize.
This is interesting. This isn't related to channels, but this is related to nullable reference types. The generics and nullable reference types have an interesting relationship. And in this particular case, if the T is a reference type, when this returns false, this could actually be null.
Right.
And so this is telling me, hey, like you might be writing null into something that the consumer doesn't know.
And they might not expect.
They might not expect.
Get a null they didn't expect.
So I need to add a little annotation here that says maybe null when false.
Are you for real?
Yeah. And then
It's not like a question mark or an exclamation point?
it's like a partial question mark.
It's not like, no?
So I could do question mark,
Yeah, because this is like T?
but now this is telling the consumer that this can always be null.
Okay, so let's be real clear. So T with a question mark is like,
Might be null.
could be null.
Yeah.
You don't know. And then what's exclamation point? Hey!
Yeah, exclamation point doesn't actually exist in the C# syntax, but if it did, it would be this is not null.
Yeah, okay. And then it could be null, could go either way.
Yeah, and then there are these attributes that allow you to hedge your bet.
Who are you telling that attribute to?
Consumers of this method.
All right.
Yeah. So a consumer of this method, back up here, if I tried to here do item dot toString,
Yeah.
then, well, if all my other things were resolved, I would end up with a nullability error here saying this isn't guaranteed.
It would give you a heads up.
Yeah,
Okay, and that heads up is flowing upwards in the call stack because of that attribute.
exactly.
Cool.
And actually, in this particular case, I wouldn't get one because the T is an int. But if the T were a string, then I would.
Yeah,
get
a nullable type.
Yeah. All right, so I've got try read. Try read is pretty easy. Wait to read is harder. So wait to read looks like this. We've got a value task bool. I'm just going to get rid of the implementation just to show the signature. So wait to read ends up looking kind of similar to read async. So let's start by just copying that implementation. What we want here is we want to return true, basically, if there is data available, and false if it's completed such that it will never be data available. So it's if the items.count.
So if false in this case is don't even bother coming back, we're done now.
Exactly.
Okay.
So if there is an item available, we're good to go.
Right, now I want to make sure that, because not everyone might be following all of this, this is not just return false or return true. It's return new value task of bool that is true.
Yes.
And for some people that might feel verbose, but they need to understand the context in which that they're working is one that we are passing around value tasks and not just bools.
And I could make this less verbose if I wanted to. I could use, allow the compiler to infer it, and that'll work just fine.
Okay, that's an interesting thing to call out, right? So 86 and 92 here are expressing similar things. One's returning true value task of true, one is not. It's just syntactic sugar.
The compiler exactly, other than the argument I'm passing, they'll compile exactly the same way.
Cool.
Yeah. So now this is the hard part now. What do I do when, again, I kind of need to hand you that envelope? That's where I promise I'm going to fill it in when I know the answer. But I can't use the same thing that I already have. I can't use this task completion source of this queue of readers because I'm not actually giving you any data. So, and interestingly, I don't even need a different one per waiter because I'm not promising you a particular piece of data. I'm just giving a notification. I can broadcast that notification to anyone who's waiting. So I can just use a single task completion source of bool. Let's call that waiting readers. And we're going to make this nullable so that I can fill it in later. And now my waiters down here, I'm going to say waiting readers, and I'm going to create a brand new task completion source if there wasn't already one. If there is already one, we can just reuse it.
And double question mark equals is?
Double question mark equals is the same as waiting readers double question mark,
which is
the same as, you're going to make me figure this out, which is the same as if waiting readers is null, then waiting readers is given the value of new.
Yeah.
Yeah.
I just think it's really cool because maybe just give me just a little bit bigger fonts, just a skosh. I think that when we see these kinds of things, like I joke a little bit when I go like the question mark is like, but that's how I'm reading it in my head because these symbols are chosen for their mouth feel, for their texture, just as you want the
Yummy.
API to feel a certain way. You know what I mean? Like that double question mark starts to kind of make sense. And then when you have double question mark equals, that should feel right once you see how it unfolds. So I like to call that out.
Yep. All right. So we're almost done. We've implemented wait to read async, but now we actually need to notify these waiters. The other methods haven't paid any attention to this. So our writer up here, in addition to checking for readers, now when it's queuing a new item, it needs to notify these readers. So it's, if there are any waiting readers, it sets it to true, and then it nulls it out so that the next time you don't have an issue. And we'll do the same thing in completion, except here we will say, if waiting readers, that will set it the result to false.
Now this might be a dumb question, but when I'm doing like high-level text boxes over data, you know, businessy, enterprisey, blah, blah, blah type stuff, when I see 3 or 4 lines of code duplicated, I start to get a little twitchy. Mm-hmm. Do you feel the same way when you're writing lower-level code? Because if you started to go, well, these 3 lines are over here, I need to not repeat myself, and you start pulling things into helper functions, it can become a lot less readable. Mm-hmm. When you're building plumbing, do you think about stuff like that?
Absolutely.
Okay.
Especially because I'm pretty sure this code has a bug that we're going to experience in a couple minutes.
So you're not feeling comfortable?
I'm not feeling comfortable.
Okay, because you've been copy-pasting?
Yes.
A lot.
And I'm going to have to fix that same bug in multiple places.
Okay.
But we'll see that in a moment.
Let's see.
Yes, I definitely try and refactor things so that I'm not expressing the same concept multiple times.
Okay.
Great. So we should see that. Oh,
do me a favor, just make sure that we kind of like reset. Can you collapse everything to our definitions? I want to just make sure that we know the shape of this, or maybe show us, like zoom in and show us our methods here.
Yep.
You got Zoom It installed?
Yep. Oh, I restarted. Hold on.
Uh-oh. Because Russinovich will get mad at you if you don't have Zoom It running in startup.
I restarted, so yeah, I don't have it on startup. Sorry.
No, I know he's a stern taskmaster.
There we go.
Okay, so that is the shape of what we've got right now.
Yep.
Right? Complete read async, try read, wait to read, and write async, and then we've got the sync object.
And the only difference from the surface area, other than it being distributed between the reader side and the writer side, the only methods that we're really missing here fundamentally from the actual channels is the wait to read async has a wait to write async counterpart, mm-hmm. and the try read has a try write counterpart, which don't matter for an unbounded channel because there's always room to write.
Okay. And the concept of channels is not a new one. This has happened in the late 70s. Mm-hmm. And then other languages have channels. Like Go is well known for channels.
It's a fundamental, it is the synchronization primitive in Go.
Okay. And we have lots of different synchronization primitives?
Yeah,
lots of different ways?
Mutexes and monitors and semaphores. And so in .NET, channels ends up being sort of one tool in your tool belt. And it shows up as a library, whereas in Go, it is sort of the tool in your tool belt, and it is in the language.
Okay, and that's neither bad nor good. It's just simply
different
a thing.
choice.
So as you're learning different languages, whether it be English, French, or Finnish, you're going to discover what idiomatic that language feels like.
But fundamentally, they represent the same concept.
Cool.
Yeah. Great. So we should be able to run this, and in theory, this should print out the same 0 through 9 and then end. Okay. I suspect what's going to happen is that's not going to work.
It's a lot of work to just do 0 through 9.
It is a lot of work to do 0 through 9. Oh, it did work. No, it didn't work.
No, it got to 1.
Yeah.
And then it's going to wait forever?
Yeah.
Are we deadlocked?
Well, yes and no. I think we're live locked.
Oh. What does that mean?
It means we're spinning.
We're spin locked.
Yeah.
Is that the same thing?
Well, no.
That's why I asked.
A spin lock is where you're using.
Spin lock's a noun. Are we verbed?
We're verbed.
Okay.
Yeah.
So we're not.
So spin lock is a synchronization primitive where you've got a lock.
Right.
But rather than actually blocking in the kernel, you're sort of spinning, polling, waiting for something.
Right. We're good.
Exactly.
We cool. That's a spin lock.
That's a spin lock.
Yeah.
Very annoying spin lock.
Yeah. Thank you.
Yeah. Live locked is when it's a symptom, like you might experience that if the condition that you're waiting for never happens. So you're just kind of going.
Oh, okay. So this is like when you and I follow each other. We're coming to each other in the hall, and we kind of go. And then you can do that for eternity.
Exactly.
Okay.
Never
That's what's happening right now.
I'm
inside.
pretty sure that's what's happening.
Yeah.
So we can debug it and see.
All right.
And then we'll figure out why.
We can do debugging.
Yeah.
I thought we just do console.writeline. Isn't that what the? Everyone just debugs that way.
I mean, we could.
No, God no.
I am a big fan of printf debugging, but in this case, we're going to break into the debugger. I am also a big fan, you can see I already even have it up, of the parallel stacks window. So we're going to bring that up, just so I can confirm that, yeah.
There are people there are very well-known distinguished engineers whose names I will not mention, who don't do debugging. They do console.writeline, they do printf, they do got here.
I do that.
Debugging, you just go got here, got here, or didn't get there, it must be between those two lines.
There are times when that is the right answer.
Yeah?
Yeah.
There are times. But then there's times when you get a cool chart that looks like Visio.
That's right. This is pretty cool. So this, for anyone who hasn't seen it, this is one of my favorite things in Visual Studio. This is the parallel stacks window. It's been around since like 2010, 2008, something in that time frame.
Yeah.
And it just shows you all your threads in one view and coalesces them. So you can see 3 threads. I can zoom in.
Yeah, I feel very fancy when I'm in the parallel stacks.
Yeah, if you feel
like I'm reading computer science.
Yeah. So you can see like 3 threads are here in worker thread start, and then 2 of them branched off on this path, and 1 of them branched off on this path.
Cool.
And you asked if we were deadlocked. If we were deadlocked, if I were to hit F10, nothing would happen.
Okay.
But if I hit F10, I think we're going to see that I'm still moving. But we're just constantly looping.
Got it.
So what I think is happening, and this confirmed it when I looked at it. Let me see if I can zoom in a little bit. So this is the stack we're on. You see we're inside try read. But if you zoom up the stack a little bit, you can see we're also inside write. Yeah.
How do we get into read from write?
So write is calling set result. Set result is then running its continuations. So anyone who hooked up a continuation to this task to say, hey, when your task is done, please invoke me. Well, this is then running those continuations right here, which is calling back into our main method, which is calling try read. And the reason that's a problem is, part of the problem is locks in .NET, monitors, the thing that we get here. These are what are called reentrant locks. And that means that if you're holding one and you try and take it again on the same thread, it will succeed. And it retains a reference count of how many times you've entered. Now, the thing about locks is the whole reason we take locks is to maintain invariance. So you change multiple things and you want those all to happen atomically. When you re-enter one of these reentrantly, your invariance may not hold, because if if I recursively called something from the middle of this function, anything that was done after the point that I'm at hasn't happened yet. And you'll notice here...
And it'll never happen until the whole thing unfolds.
Exactly. And here, we're completing the continuations before we null out the readers.
That's pretty subtle.
Yeah. Which means that down here in wait to read async, if we call wait to read async again, there's nothing in the queue, so it won't return true. It's not completed, so it will return false. It'll check to see if there's already an initialized waiting readers, and there will be, that has already been completed. So it'll be returning something that is already completed with true. Then we'll call try read. Try read will try and dequeue something. It'll fail. We'll go back to waiting to read. Waiting to read, we'll see nothing in the queue, and we're just in a loop.
Got it.
So the simple fix, or the Band-Aid, as it were, would be to just change how we're doing this code here. So
it's not comforting, by the way. Anytime you're using air quotes,
it's not comforting.
Nothing good happens in air quotes.
Exactly. So I could say waiting readers, then I'm going to null out this, and then I'll say waiting readers set result true. And again, this is just fancy syntax for...
if it's null, if it's not null, do it. If otherwise, don't.
Exactly. Yeah. And I can do that again down the other place I had it again. This gets to your comment about, I didn't mean to delete that.
I think you torched it there.
I did. Yeah, that was, that would have been another bug. I can go back down here to the other place that I was doing this, to your comment about me.
Yeah, do me a favor.
Yeah.
Put them next to each other, before and after. I don't think people can hold more than a couple lines of code in their head, and you might be able to hold pages. All right, show me the before and after. Do me a favor.
Before?
I'm going to do it. Yeah, I'm going to do it this way. So, this here. Did you have? You've got a freaking ThinkPad with the function key. What is
sorry.
it? The FN key. What is that? Okay, so this is when. That's before.
That's before.
Okay, let's all look at that. Go. Yes, I see. Do you all understand how the ordering has changed and why that's important? Okay. Because you've done two things here. You've added the not null down here.
Yeah.
And that makes it look like multiple things have changed at once.
Yeah.
Okay, cool.
So we're going to get rid of this one. So
Yes, sir.
I think this will run successfully now. Yeah. And then what we should see is when we get to the end, there won't be an exception because the wait to read async will just return false and will be.
And then it'll exit cleanly.
Right. So that's nice, but it hasn't actually fixed the problem, and there are probably other ways that
You say it hasn't actually fixed the problem. It's buried, it's latent, it can still happen.
it is. If there are other ways that this could possibly manifest, and I want to avoid that completely. Now, it is arguable that this is our fault, and by us I mean
By you.
me.
I was just watching.
Yeah, and yes, our fault meaning the .NET team
Okay, good.
and me.
Yeah.
Yeah. And it's quite possible that the answer should have been that by default the right thing, the safe thing happens, and you opt into a performance optimization. Because this is that synchronous invocation of the continuation is a performance optimization. The way you avoid that is anywhere we're creating one of these task completion sources. So let me just search for task completion source. So right here we're creating one. There's an option I can pass, task creation options, run continuations asynchronously. And this will ensure that whenever I set this, when I set results, set canceled, set exception, any continuations will forcibly be run asynchronously, not synchronously as part of this. So I'm going to pass that to both here, and I think I was creating one in one other place. And I could revert now that the change that I made around setting the thing to null, and it would still work.
Okay, should you still be extra defensive and set it to null? Or are you...
Doesn't really matter. I mean, I still
being
need to set it to
careful
null, but
twice.
the order no longer matters.
Okay, that's the trick. That's why I was asking.
Yeah.
Because by simply changing the order, things were fixed, but the fundamental issue was that the continuations were not happening asynchronously.
Exactly.
Once you fix that, this order doesn't matter, and it's a tighter, cleaner algorithm.
Exactly. Now, one of the reasons I was saying that there was still an issue here is if I didn't do that, I'm still synchronously running any continuations, which means I'm still synchronously doing them while holding the lock. And you never want to call out to unknown code while you're holding the lock.
So those continuations firing off are a side effect, and if you are not aware that you're in the middle of this lock or you forget,
Yeah.
then you're going to
And so if you're not going to, in the places where we ourselves don't set run continuations asynchronously, we'll manually do the work to make sure that this set result call doesn't happen as part of any lock. And in fact, you'll see places in the .NET library code base where we'll explicitly say this is using run continuations asynchronously because we need to escape some lock that's held higher up the call stack. And we need to make sure that the continuations aren't run as part of that. Cool. So this, we can see this should still work even after I made that change. It hasn't fundamentally changed anything. It's just guaranteed.
When you write this kind of stuff, I love that right now you're like, this will probably work, and then you run it and you go, yeah, I went to 10, it's cool. How are you doing that when you're actually working on .NET? Do you write like 20 tests, 100 tests around it?
More than 20.
More than 20.
Yeah.
22 tests.
222 tests maybe.
Hundreds.
And often it's parameterized, it's theories. You're trying to do as much as you can with as few tests as you can write.
He just said theories. In the XUnit framework, there's this thing called a fact, which is like, this is a test. And then the theory is, this is n number of tests. Right. So you're going to have a combinatoric
So we'll write one test that will parameterize with a whole bunch of inputs to validate different use cases. I don't know how many tests are actually in the channels library, but it's hundreds.
A lot.
Yeah. And we'll try and reuse as much as possible. So we'll have a shared test base with tests that will apply to all the different kinds of channels. And then we'll derive from that to have ones that are specialized for unbounded and ones that are specialized for bounded and so on.
Now, I have a question, and you tell me if you want to spend the time on it or not, but I was talking with someone about the differences between CPUs, GPUs, and NPUs, and then we started talking about instruction sets and coprocessors and not having coprocessors, or MMX instruction sets and SSC instruction sets. And there's instruction sets that are added to processors that have been added to Intel processors and AMD processors for the last 30 plus years. How high level is this? Feels low level for the average Joe and Jane .NET developer, but are you also, as .NET developers and performance people, thinking about like, oh, well, the 7th gen Intel added this thing and they changed the width of the other thing? You know,
There are definitely developers on our team that say that sentence.
yeah? Did they go
But
like this?
not while working on this library.
Okay. So this is going to work no matter what. This is computer science, and there's no dependencies on a certain shape or behavior of certain instruction sets on certain processors.
Right, with the exception that you talked about spin locks before. Like there are places where we will try and use low lock techniques to optimize performance. And once you start getting into low lock techniques, you need to start paying more attention to a little bit more of the intricacies of the hardware. And for the most part, we hope that that's handled for us at the lower layers. For example, spin locks typically rely on pause instructions being inserted so that the hardware level is waiting for a certain amount of time before, we're measured in small number of cycles. But those instructions have changed over time. So it used to be that Intel's pause instruction was like 10 cycles, and then they made a change in some hardware, I don't remember how long ago.
And is there like a subculture of people that talk about this on Reddit?
There are. There are whole little pockets of people that love discussing this stuff.
But we at .NET, we who use .NET don't have to think about that.
No, but people who implement .NET, so I think it changed from like 10 cycles to 140 cycles.
Do you have that browser site still up from, we were talking about this earlier? You can go Control-Shift-T.
Intel pause. Somewhere here.
Pause for effect.
No pun intended.
Do you know about Control-Shift-T?
No, what's that?
It's undoing closing the tab you just closed.
I did not know that.
Yeah, change it.
Yeah, so you can see like Sandy Bridge was 11 clock cycles and Skylake was like 140.
Okay, so that matters to someone, not us today.
To the point where, well, it matters. If we didn't do anything in .NET about it, it would matter to anyone who was implementing anything on top of anything that used a spin lock. What some enterprising people on the .NET team did was .NET itself at startup basically is measuring the cost of a pause instruction and then is tuning the spin locks accordingly.
That's cool. Thank you for doing that.
You're very welcome. It wasn't me, but I'll pass it along. Yeah.
I'll take that feedback to the team.
Exactly.
No one is ever going to.
But in this library, there's. In this library, there's basically none of that. There's very little to no specialization here, other than the channels library does work on .NET, not only .NET 8, 9, 10, but also .NET Framework. It targets .NET Standard, and so.
And Windows and Linux and Mac.
Oh, of course, across the board. Yeah. But we have there's, to my knowledge, I don't think there's any code in the channels library that is specialized per OS. But there are places where we take advantage of APIs that don't exist on .NET Framework that do exist on Core. And so there's a different build that you use on .NET Framework. Like the NuGet package contains an asset for NetFX and an asset for.
But we all get this. And this is one of these things that has been around for a long time. This started around .NET Core 3?
Yeah, around 3, I think.
Yeah, so it's been like 7 or 8 years, and I think it's one of the gems of .NET.
Just to mention, this is also not exactly, like this isn't the most idiomatic code. I'd like to be able to write this a little bit easier. So there's actually a method on channel that exposes that exact looping structure we just saw as an async enumerable. So I'm going to just write here async enumerable of t. It's going to write it for me. And you can see it's the exact same thing. And now up here, instead of doing this same looping, I can just write await for each var item. And we'll do.
Yeah, you're too fast.
Sorry.
Slow down, brother. Come on. People are freaking out. All right, sorry.
Before and after.
Yeah. All right, thank you.
Yeah. And then, again, we'll get the same behavior. But we got to write the simpler.
So watching smart people code is just like beep, boop, bop, boop, boop, boop. I have no idea what's happening. That removed the try, and you buried it down at the bottom.
Exactly. And so now this is effectively the same structurally as what shows up in the actual libraries. If you look at the actual implementation, there's a lot more code. Most of it is for perf reasons. So given that, why don't we write a little perf test?
Let's do it.
See what this looks like. So I'm going to make a few tweaks here. I'm going to get rid of this delay. We're going to have this loop just infinitely writing into this channel. I'm going to add a counter here to see.
We're going to overflow an int today.
I mean, it might actually, but
that'd be awesome.
And we're just going to just increment this. And then I'm just going to launch. This is a very, simplistic, naive perf test. I'm just going to launch another task that's going to sit in a loop. So say.
Well, you got an int consumed is a long and int is the loop is an int.
Yeah, I just want to make sure I'm not going to overflow it. I don't think I will, but
Okay.
And I'm going to say start will be consumed, then thread sleep. Yeah, we'll do that, and then
We're never going to overflow anything at that rate.
right.
Make me wait.
Yeah, I don't need all this extra text. Get rid of that. And then I just have a personal preference. I like seeing my numbers written with commas, so we'll add a little.
That's another little spice that I think people don't realize, that you can go and take a variable and then put a colon and then have your format string there, as opposed to going string.format.
Nice and
Yeah.
nice and neat. So now what's happening is we've got our writer writing as fast as it can, our consumer consuming as fast as it can, and we have this other thread that's just sitting out here that's measuring, sleeping for a second, measuring, and then showing the difference. So let me run this in release, and we'll see what we see.
We're running it in release to remove any kind of variables and other.
Yeah, so we're basically pumping through about 4-5 million messages per second.
I wonder if my laptop is faster than yours.
This actually, something just happened. It dipped down, but it doesn't. It's a nice little.
You should throw that into GitHub or something and let me run it over here.
Okay.
Just think, I don't know. We don't have to do that. It's okay. It's fine.
I feel like I would spend the next 13 minutes figuring out how to do that.
How to push something from Git.
Yeah. The other thing I like to do, especially with is just a profile to see what we see. So let's run the profiler.
Oh, this is so good. Another delightful place that people don't visit here enough.
Yes, debug performance profiler.
Yes.
And there are lots of different kinds of profilers here. You can do a profiler for async, you can get various counters, database stuff, GPU. The two that I end up using most are the CPU usage and the .NET Object Allocation Tracking. So this one, the Object Allocation Tracking, basically tracks every single object that you create and then shows you information about where they were coming from and what types and whatnot. And the CPU one is just doing sampling for all of your stacks and showing you where you're spending.
And why do some exclude the other? Like when you did that one, it excluded this one. You did this one, it excluded that.
Mostly for performance reasons. So this one is super expensive, and if you had both the object allocation tracking enabled, your CPU usage information would be useless.
Gotcha.
So the team kind of knows that and disables the ones that are effectively incompatible.
Dig it.
So we're going to launch that. We'll let this run a little bit. You can see it's a little bit slower on average because there's some overhead associated with this tracking.
Cool.
It's also
Still millions.
Yeah. It's also if I were to run it again, we might get different numbers. This isn't a bulletproof perf test, but you kind of get the idea. So it's gathering all the data, and it's going to come back with details that we can dig into, high-level details about where all of our time is being spent, and we can drill into that and learn more about and I can go over here to just make sure I'm so I can say open details, and then I can view this in different ways. So for example, I could view a flame graph of where all my time is being spent, and I can drill in and optimize it. I said I wasn't going to use agents, and that is true, I'm not. But I do personally like this little button here.
Which button are we looking at?
The Copilot one.
Okay.
So I'm going to show it just because I do personally use it, and I'm curious to see what it's going to say.
So you're going to ask Copilot what it thinks about the stuff that's going on here.
Yeah. Now, interestingly, it's having a little trouble with the source, I think because I use the top level.
Aren't you in release? Does it matter?
It doesn't matter.
Okay.
I think it's having trouble because of the anonymous method that's showing up in my top level. So I'll just say that's just a lambda in my top level.
So you're just basically saying, trust me, bro, to the
Exactly.
Copilot?
Yeah. And after this, I'm going to go follow up with the team to say what.
Fix that? Yeah.
So it's coming back with. I'm going to zoom in. It's recognized that I'm doing this consumer producer things. It understands. It's saying.
It says complete. It's just telling you, you invented this thing and you wrote this, but it's telling you that you should think about optimizing.
Right. So it's telling you various things. Like there are various ways I can improve this. Maybe I need to add some back pressure. That would be like adding a bounded channel for an unbounded pressure. But the interesting one that you pointed out is it's telling me I should consider being more granular with my locks, which is actually what the actual implementation does. It uses lock-free data structure.
You kind of locked at the open. You come into the function, you lock right away, and you have quite a bit of space in your lock.
Exactly. Now, in the 10 minutes that we have left, we can't have a fully lock-free implementation, but we can get pretty close.
In 10 minutes?
Yeah, maybe like 5.
Go.
Okay. So instead of a queue, we're going to use a concurrent queue.
Okay.
Okay? A concurrent queue is basically a queue that has its own synchronization built into it. So I can enqueue and dequeue without having to take a lock. And the data structure itself is protected. Now, if I was trying to coordinate with other things, I might have to add my own atomicity. But just for working with this data structure directly, I don't need any locking. And that means that in something like read, where the only thing that I was doing was just dequeuing, right? I'm just going to get rid of that.
Sweet.
Okay?
Refactoring via subtraction.
Exactly. And then in read async, I'm just going to copy this and
do it outside.
Now I'm going to leave the one inside as well, just to make sure I haven't fully vetted that, does the writer actually, is it setting state in a way where it would be okay if I eliminated the one inside the lock? This is basically what's called double check locking,
okay.
Where I do a check, a kind of fast check outside the lock, and then I take the lock and I recheck just to make sure.
And it's okay. You're not going to dequeue things twice because it's a return.
Right.
You're not setting it into a variable.
Exactly. And then here, so count on a concurrent queue is not the cheapest operation in the world, but it does have an isEmpty, which we can use. Oh, you know what? I just realized I'm missing a lock statement here.
How has this been working?
Yeah.
That whole thing should have been locked.
Yeah, the whole thing should have been locked.
Come on, man. Get good.
I know. Sorry.
Filthy casual.
So again, I'm just going to do a double check locking thing here.
Okay. Cool.
Am I missing any other locks? No, we're good. Okay.
Sorry. I just look. That's cool.
Yeah, we're good to go. Ship it.
Ship it. Straight to
Okay,
production.
so let's ship it.
Wah!
So, yeah. Pretty good, right? I mean, you can bow to concurrent queue. But that's, that's why we profile. That's why we try and get this insight.
Okay, so this brings me to Tobe posting.
Yes.
Right? You go and you roll up every year a performance blog post. If you haven't read it, it'll actually crash your browser. It is like they're using it to performance test browsers.
Safari, yeah.
Was it 23 megs this year?
Oh, it was pretty big.
Yeah. You're collecting all of the different things that you and the team and everyone is kind of doing. And I always wonder when we make it 10x faster, it's just like, oh, did we suck 10x before? But you're always finding more. Like, that's shocking. You just doubled it. But there's probably more things and more and more and more. You'll always be discovering.
There's always more.
A way to squeeze.
A lot. Some of it is areas that we haven't explored before. For some reason, there wasn't a spotlight on that area. And for whatever reason, someone now cares and made noise about it, and so we went and looked. And you can always squeeze out a little bit more if you go and look.
That's awesome.
Sometimes it's things where the capabilities just weren't there to do it in an easy enough way. But something else over here got added that we could then take advantage of over here to make it faster. So a good example of that is there were a bunch of places where, and this is around the .NET 8 timeframe, where if you went and looked across all of .NET, there were maybe like 50 or 60 places where there was a loop for I equals 0, I is less than array or string.length. Look at the next character in the string or the next whatever and do something. And we're like trying to find something. And you're doing something for every single character. And unless you write a large volume of code for each of those places, it's just not worth it. But then in .NET 8, we added search values of t, which encapsulates a highly optimized implementation of that. And then we can go, once that exists, we can go and update those 50 or 60 places with that optimized implementation. And so those aren't improvements that we necessarily didn't want to make in the past. Maybe we did, but we just didn't have the tools to do it well.
Yep.
And search, to your question, your comment earlier, like search values is special casing x86 and SSC2 and AVX2 and AVX512 and like all those. We wouldn't have wanted to do that in all those 60 different places. But once it's been encapsulated in the one thing over here, we can then go find all the places and use it.
Yeah, and you're running around making changes. And like this is the hot path, and then it's no longer the hot path, and then there's a new hot path.
Exactly. Sometimes it's also not us. Sometimes it's people from the community coming to the repo saying, hey, this thing over here that you don't really care about, I care about. So I'm going to help make it faster because it's important to my application. Mm-hmm. And while we might not have spent time implementing and optimizing it, we'll happily spend time reviewing and helping get that merged if it's an improvement. So.
Do you, just out of curiosity, we only have a couple minutes left, but what is the speed difference between the one that you ship versus the one that you wrote in a half an hour? But that was 10 million.
Yeah, the one that we ship is approximately the same as the 10 million, but with some more functionality.
Okay.
So it kind of, it gives up some, could have been more perf in exchange for other capabilities.
Similar perf, but all this more utility and more available information. Very cool.
Yeah.
All right.
The only other thing to highlight, I don't want to spill this on my laptop. The only other thing to highlight, we saw earlier that there are, if I do channel.create unbounded, there's also bounded, and all bounded is oh, I don't need to do any of those options. The main thing that the difference is that there is a bound. So rather than not having any limit on the number of things you can store, with create bounded, you specify the upper bound. And this is that back pressure that the Copilot was suggesting we might want to consider.
Aren't there channels in other languages and worlds that have a third? There's bounded, unbounded, and?
So Go has effectively unbuffered, which is basically bounded with a capacity of 0. And that means that rather than putting something into a buffer, the producer and the consumer have to be there at the exact same time. And we've had an issue open for a few years in runtime to add that. And we just keep not getting to it. I'm really hopeful we will for .NET 10.
Or pull requests?
Or a pull request, yeah. The tricky thing there
Maybe you
is,
can do that for us.
the tricky thing with unbuffered for .NET in particular is it's a no-brainer if you're just doing read async and write async, or if you're doing read async with try write or write async with try read. But the moment you have try read and try write, and those are basically instantaneous operations, and they can basically never line up. So if you have one of those channels, you can end up in a situation where no one's able to talk to anyone. So we'll have to figure that out, but yeah.
Cool.
Yeah. So the thing I wanted to highlight is to create a bounded channel, and I'm not going to do the full implementation. It's almost exactly the same, except instead of just having readers and waiting readers, we'd also end up having writers and waiting writers. And the writers are going to be a little different. They're going to basically be a tuple of a value and a task completion source, which we'll call TCS. And so basically, we just need to go through those 5 methods or whatever and add the extra case. So when we're saying read async, if we go from full to not full, then we need to alert the writers and that kind of thing. And that's it. And that's channels. That's the entire library in
58 minutes.
58 minutes.
Yeah. So if you like this kind of stuff, check out deep.net. We had one where we did array pool, spent an hour doing array pool. Comments were that somebody wanted the 5-hour director's cut extended edition. So, we did a deep dive into LINQ for 83 minutes. I learned a lot. It feels like going to school every time we get to hang out with you.
I love it.
Be sure to check out the deep.net collection. We've done 10 so far. We've also had other folks on the show. We've done array pool. We've done AOT. We talked about Python and C snakes. It's just great fun, and we hope that you enjoyed this highly technical talk. Let's give Stephen a big round of applause. All right, friends. Have a great show, and we'll see you a little bit later in the hallway.
Thanks a lot.